Welcome to the next video on factoring trinomials. We are going to look at what we call hard trinomials, when we have a trinomial with the coefficient is bigger than 1. Now there are many ways to factor these so-called hard trinomials. I call them hard trinomials for my students when that number in the front of the x squared is not a 1. I am going to use the method called decomposition because I think that is the one that is most commonly used across the province of New Brunswick. Personally, I prefer a method called Australian method, and if you want to Google that, you could, and I know some other teachers use some other methods as well. So this method of decomposition, the word decomposition means to decompose, and that's what we're going to do. We're going to break down our trinomial in 3 terms into 4 terms. It starts off the same as our simple trinomials. So our simple trinomials, we said what 2 numbers multiply together to give us that a times c, and they have to add up to give us the b. The only difference here between a hard trinomial and a simple trinomial is I call the simple trinomial is when the number in front of the x squared was just a 1. This is when the number in front of the x squared is not a 1, and it takes a couple more steps. So once we find the 2 numbers, you use them to break down the middle term into 2 pieces, and like I said, I call this decomposition. And then we're going to do something called factor by grouping. It's like greatest common factor, and we're just going to do it in parts. So the first example here that I have is I have this 4x squared plus 5x minus 6. So the 2 numbers are going to multiply together. So the 4 times the negative 6 is negative 24. And then they're going to add up to give us the 5. So I'm going to have to go through the factors of 24. Maybe I'll do it over here. So I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So my 2 numbers have to multiply together to give me negative 24, but then add up to give me a 5. And the only way that that can happen is if I have a negative 3 and a plus 8. So I have negative 3 times 8 is negative 24, and negative 3 plus 8 is positive 5. So this is why they call it decomposition. We rewrite the same expression. I'm going to write the beginning and the end here. And we decompose or break down that middle term into 2 terms. And I'm going to use the numbers, this negative 3, and I'm going to put the x beside it. So I'm going to break down that 5x and call it negative 3x plus 8x, because negative 3x plus 8x is 5x. I didn't change anything. All I did was break it down into 2 terms, and what we're going to see is we're going to be able to look at those 2 terms here, and I'm going to look at this group of the 2 terms. So I'm going to break it down so I can do a greatest common factor. So I have 4x squared minus 3x. The only thing that is in common to those terms is an x, and I'm left with 4x minus 3. So I did a greatest common factor of x. Now, on the other side, I have 8x take away 6. The greatest common factor I have there is a 2, a positive 2. 8x divided by 2 is 4x, and negative 6 divided by 2 is negative 3. When I took out my greatest common factors, so I had 4 terms there. I looked for the first 2, and I looked for the second 2. And you have a binomial here. You have this 4x minus 3 that's common to both of these 2 sets. So we can say that there is a greatest common factor of 4x minus 3. And then what we have left over is this x plus 2. So the 2 things that multiply together to give us 4x squared plus 5x minus 6 was this 4x minus 3 and this x plus 2. We could always check our answer by expanding. Expanding and factoring are just opposite operations. So let's multiply it out. 4x times x is 4x squared. 4x times 2, 8x. Negative 3x. And minus 6. So I have 4x squared plus 5x minus 6. And that does match what I started out with on the other side. Okay, one more. We have 10x squared plus 13x minus 3. So again, the two numbers have to multiply together to give me negative 30. And then they're going to add up to give me this positive 13. Let me go through the factors of 30. Maybe I'll do it here. Oh, so I got 1 and 30, 2 and 15, 3 and 10, 5 and 6. So these two numbers have to come together to make a 13 somehow. So no way those can work. But you might take a little pause here and think which one's going to be the best one for the situation. They have to multiply together to give me a negative 30. So that tells me that one number has to be positive and one has to be negative. And so in other words, they have to have a difference of 13. So it's going to be the 2 and the 15, and which one's negative? A negative 2 and a positive 15 will make that 13. Okay, so this method of decomposition, I'm just going to rewrite the first term, I'm going to jump over here and rewrite the second term, and I'm going to break this down into the two numbers. So it was a negative 2x, I want it red, negative 2x and a positive 15. So I took 3 terms and changed it into 4 terms. So I decomposed the middle term. Now I'm going to do factor by grouping. So let's look at these first 2 terms. There's a common factor of 2 and x. 10x squared divided by 2x is 5x. Negative 2x divided by 2x is 1. So I have to have the 1 there to hold the place. A 15 and a negative 3. So I have a greatest common factor here of 3, and it's going to be a positive 3. Leaves me with 5x minus 1. So one nice little thing here is you always know you're on the right track if the binomials end up being the same. Sometimes you might have to factor out a negative to make the signs the same. Sometimes you might even just have to factor out a 1. If it already looks like what you want to have, you can always factor out a positive 1 and it won't change the sign. So the two binomials that multiply together to give us that 10x squared plus 13x minus 3 would be 5x minus 1 and 2x plus 3. You could check your answer by expanding that out. And like I said, this is not the only method. Feel free to check on the web if you wanted to see another method or check with your local math teacher. But this is probably the one that's most commonly used. Thank you and have a great day.